Hello children, let us see remaining two scenarios with the help of two questions. Third question, block A is placed on block B as shown in the figure. An increasing horizontal force F is applied on block B. Part A, find the maximum value of F so that both the blocks don't move. Part B, find the maximum value of F so that block A does not slide on block B. Part C. If F is increased beyond the value obtained in Part B, what are accelerations of both the blocks? Part D. If F is equal to 15t, draw acceleration time graph. Block B is kept on a rough floor. Block A is kept on Block B. An increasing horizontal force F is applied on Block B. Mass of Block A is 10 kg and mass of Block B is 20 kg. Coefficient of static and kinetic frictions between these two contact surfaces is given. We have to answer these four parts. First step, we will calculate direction and magnitude of friction forces. Block B is kept on rough floor. That means there is some friction force working between block B and the floor. Block B is getting pulled in forward direction. That means it will move in forward direction. Floor will apply a friction force on this block in opposite direction. Let us say this is contact surface 1 and this is contact surface 2. So the friction force that floor applies on block B is represented by F2S. There is no external force working on block A, but still it will move in forward direction along with block B. That means there is some force working on it in forward direction, and that force is friction force. So block A will move only due to friction force. It will work on its lower surface in forward direction. It is represented by F1S. An equal and opposite force will work on block B on its upper surface, which is in contact with block A, because they make action reaction there. Now we know the direction of friction forces. Next, we will calculate magnitude of friction forces. F1S is less than or equal to mu S1 into N1. N1 is the normal reaction that will work vertically upwards on this contact surface. N1 is equal to Ma into G, that will work vertically downwards. Value of mu S1 is given as 0.15. Ma is given as 10 kg. We can take G as 10 meter per second square. So F1S is less than or equal to 15 Newton. Similarly, we can calculate F1K, which is kinetic friction. F1K is equal to mu K1 into Ma into G. Mu K1 is given as 0.10. Ma is 10 kg and G is 10 meter per second square. So F1K is equal to 10 Newton. F2S is less than or equal to mu S2 into N2. N2 is the normal reaction that will work vertically upwards on this contact surface. So N2 is equal to Ma plus Mb into G. Mu S2 is given as 0.25. Ma is given as 10 kg and Mb is given as 20 kg. G is 10 meter per second square. So F2S is less than or equal to 75 Newton. Similarly, we can calculate F2K, which will be equal to mu K2 into Ma plus Mb into G. Value of mu K2 is given as 0.20. So F2K is equal to 60 Newton. Now we are ready to answer part A. Find the maximum value of F so that both the blocks don't move. That maximum value of F will be equal to F2SM, which is working between block B and the ground. Its value will be equal to 75 Newton. Second step, calculate maximum acceleration of the block which is moving due to friction force only. Block A is moving due to friction force only. Its limiting friction is 15 Newton. So it can reach a maximum acceleration of F1S upon Ma, that is 15 Newton upon 10 kg, which is 1.5 meter per second square. Third step, sequence of slipping. When F is less than or equal to 75 Newton, both the blocks will remain stationary. When F is greater than 75 Newton, block B will start slipping on the floor, taking along block A with it. So both the blocks will move together till their acceleration is 1.5 meter per second square. Till that moment, we can consider them as a single body on which external force F is getting applied. Since both the blocks are moving, so we will consider kinetic friction force working on block B. So their acceleration will be AA is equal to AB is equal to F minus F2K upon MA plus MB. AA is equal to AB is equal to 1.5 meter per second square. We have to calculate the value of external force F. F2K we have calculated 60 Newton. MA is given as 10 kg. MB is given as 20 kg. So F comes out to be equal to 105 Newton. This is answer of part B. Find the maximum value of F so that block A does not slide on block B or both the blocks move together. When F is greater than 105 Newton, block B will start accelerating beyond 1.5 meter per second square. But block A cannot, as its maximum acceleration is 1.5 meter per second square. As a result, block A will start slipping on block B. Part C. When external force F is greater than 105 Newton, block A will start slipping on block B. We will consider them as separate bodies. So acceleration of block A is equal to F1K upon MA. F1K we have calculated as 10 Newton. MA is given as 10 kg. So acceleration of block A will be equal to 1 meter per second square, which is constant. Acceleration of block B is equal to F minus F1K plus F2K upon MB. That is F minus F1K we have calculated as 10 Newton and F2K we have calculated as 60 Newton. MB is given as 20 kg. So AB will be given by the formula F minus 70 upon 20 meter per second square. Part D, F is equal to 15t. We have to draw acceleration time graph. First, we will figure out various time intervals and then acceleration of both the blocks in those time intervals. When F is less than or equal to 75 newtons, both the blocks are not moving. Their acceleration is 0. Put F is equal to 15t. So 15t is less than or equal to 75 or t is less than or equal to 5 seconds. So between time interval t is equal to 0 to t is equal to 5 seconds, blocks are stationary. When F is greater than 75 Newton but less than 105 Newton, that means between time interval t is equal to 5 seconds to t is equal to 7 seconds, both the blocks are moving together and their acceleration is given by the formula t by 2 minus 2. When F is greater than 105 Newton, block A starts slipping on block B. Acceleration of block A is equal to 1 meter per second square and acceleration of block B is equal to F minus 70 upon 20. Put F is equal to 15t. So acceleration of B is given by the formula 3t by 4 minus 3.5 meter per second square. Now we have got time interval and acceleration of both the blocks in those time intervals. So we can plot a t graph easily. Fourth question. In the given figure, block A is kept on rough horizontal ground. Block A is placed on it. An increasing horizontal force F is applied on block A. Part A. Find maximum value of F so that none of the blocks move. Which block starts sliding first? Part B. Find accelerations of both the blocks for all values of F. It is given that block B is kept on rough floor. Block A is kept on block B. An increasing horizontal force F is applied on block A. Mass of both the blocks is 10 kg. Coefficients of static and kinetic frictions between these two contact surfaces is given. We have to answer these two parts. First step, find out direction and magnitude of friction forces. Force F is applied on block A, so block A will move in forward direction. A friction force will be applied on block A by block B in opposite direction. It is represented by F1s. Let us say this is contact surface 1 and this is contact surface 2. An equal and opposite force will be applied by block A on upper surface of block B as they make action-reaction pair. Since block B will move forward, so floor will apply a friction force on block B in opposite direction. It is represented by F2s. Now we know the directions of friction forces. Next, we will calculate magnitude of friction forces. F1s is less than or equal to mu S1 into N1, where N1 is normal reaction that works perpendicularly upwards on this contact surface. Weight of block A is MAG that works perpendicularly downwards. So N1 is equal to MAG. So F1s is less than or equal to mu S1 into MA into G. Value of mu S1 is given as 0.60. MA is equal to 10 kg. We can take G as 10 meter per second square. So F1s is less than or equal to 60 Newton. Similarly, we can calculate F1k. F1k is equal to mu1k into MA into G. Value of mu1k is given as 0.50. So F1k is equal to 50 Newton. F2s is less than or equal to mu2s into N2, where N2 is normal reaction that works perpendicularly upwards on this contact surface. Weight of these two blocks will be MA plus MB times G that will work perpendicularly downwards. So N2 is equal to MA plus MB into G. So F2s is less than or equal to M2s into MA plus MB times G. Value of mu2s is given as 0.20. MA and MB is 10 kg. Value of G is 10 meter per second square. So F2s is less than or equal to 40 Newton. Similarly, we can calculate F2k. F2k is equal to mu2k into MA plus MB times G. Value of mu2k is given as 0.10. So F2k comes out to be equal to 20 Newton. Second step, calculate the maximum acceleration of the block which is moving due to friction force only. Block B is moving due to friction force only. On its upper surface, block A is applying a friction force in forward direction. It is represented by F1s. When block B is accelerating, floor is applying kinetic friction on block B in opposite direction. It is represented by F2k. So maximum acceleration of block B is given by AB max is equal to F1sm minus F2k upon MB. F1sm we have calculated as 60 Newton and F2k is equal to 20 Newton. MB is 10 kg. So AB max is equal to 4 meter per second square. Third step, sequence of slipping. To know that which block starts slipping first, whether A on B or B on floor, we will see F1s and F2s. F1s is less than or equal to 60 Newton and F2s is less than or equal to 40 Newton. Since F2s is less than F1s, so block B will start slipping on the floor first. Now we are ready to answer part A. Find maximum value of F so that none of the blocks move. That maximum value of F is 40 Newton. Which block starts sliding first? Block B starts sliding first. When value of F is more than 40 Newton, block B starts slipping on the floor, taking block A along with it, till their acceleration reaches 4 meter per second square. Till that point of time, we can treat them as a single body on which external force F is applied. On its bottom surface, floor is applying kinetic friction F2k. So AA is equal to AB is equal to F minus F2k upon MA plus MB. Value of F2k is equal to 20 Newton. MA is equal to MB is equal to 10 kg. So F is equal to 100 Newton. That means when value of F is between 40 Newton to 100 Newton, blocks are moving together. When F is more than 100 Newton, block A will try to accelerate beyond 4 meter per second square. But maximum acceleration of block B is 4 meter per second square. As a result, block A will start slipping on block B. When F is greater than 100 Newton, block A will start slipping on block B. So we will treat them as separate bodies. In that case, acceleration of block A is equal to F minus F1k upon MA. Value of F1k is equal to 50 Newton, MA is equal to 10 kg. So AA is equal to F minus 50 upon 10. Acceleration of block B is equal to F1k minus F2k upon MB. Value of F1k is 50 Newton, value of F2k is 20 Newton and MB is equal to 10 kg. So AB is equal to 3 meter per second square. Now we are ready to answer part B. When F is less than or equal to 40 Newton, both the blocks are stationary. So their accelerations will be equal to 0. When value of F lies between 40 Newton to 100 Newton, both the blocks will move together. So their accelerations will be same, and that is equal to F minus 20 upon 20 meter per second square. When value of F is more than 100 Newton, acceleration of block A is equal to F minus 50 upon 10 meter per second square, and acceleration of block B is equal to 3 meter per second square. In next video, we will solve previous year's JEE questions. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.